This is a really nice question and pretty easy as long as you remember your basic rules of coordinate geometry. Triangle OBA has its vertices at the origin, A, which is 3, 0, B, which is 0, 4. Point C lies on AB, OC is perpendicular to AB, and draw a diagram. So, we're going to draw our axes over here. We mainly just need positive side. And excuse me, it's very hard to draw nice diagrams on this. Okay, so O is here. A is 3, 0, so that's 3, so that's the point A. B is the point 0, 4, so that's B up there. This is not to scale, obviously. Okay, we've got AB, which is this line here. Now, C lies in AB such that O is perpendicular, so we've got a line from O which is perpendicular and meets AB at C. Okay, so that's a very rough diagram. Let's do the rest of this question. Find the equations of AB, OC, and hence find the coordinates of C. So, to find the equation of a line, we need gradient. So, the gradient of AB is going to be difference of the y coordinates. So it's 0 minus 4 over 3 minus 0, which is minus 4/3. We know a point that goes to AB, it's A, or alternately B, but we'll just use A, so therefore y minus 0 equals minus 4/3 x minus 3. Let's expand, let's turn this into general form. So we have 3y, we don't need to worry about the 0, that just disappears, equals minus 4 brackets x minus 3, which means 3y equals minus 4x plus 12. So 4x plus 3y minus 12 equals 0. Okay, so that's the equation of AB. Find the equation of OC. Well, we know that OC is perpendicular to AB, so therefore the gradient of OC is going to be the negative reciprocal, so it's going to be 3/4. We know a point. In fact, this is going to be slightly easier. Because it passes through the origin. So the line is just going to be y equals 3/4 x. Okay, you can justify that yourself, but it is quite simple like that. And then we can turn to general form. 4y equals 3x. So 3x minus 4y equals 0. Okay, so that's the equation of OC. Now, to find the coordinates of C, we need to solve these two equations simultaneously, AB and OC. What I'm going to do is I'm going to multiply the equation AB by 4 and the equation OC by 3. The reason we're going to do that is we want to make the coefficient of y the same. So, we have 16x plus 12y minus 48 equals to 0, and we have 9x minus 12y equals 0, and if we add the two equations we get 25x minus 48 equals 0, and so we have x equals 48 over 25. And if we substitute back into any of the equations, in fact we're going to be really cheeky and substitute it back into this equation back here, which is another form of the equation of OC. So we know y equals 3/4 times 40x, which is 48 over 25. So that's going to be 36 over 25. Now, again, you can justify this, but it should be pretty obvious that these are the coordinates of C. So we can just write C is 48 over 25, comma, 36 over 25. So we're done for now, but we still have 2 parts to go. Okay, so the rest of the question should be pretty straightforward because we're just using the distance formula. The distance between O and A is easy because it's just going to be 3 units. Because it just lies in the axis. Similarly, the distance of AB. Well, we could use the distance formula, but it's probably easy just to notice we've got a Pythagoras question, so it's just square root of 3 squared plus 4 squared, which if you know the common 3, 4, 5 triangle is just going to be 5. That's easy. Now, the rest is a tiny bit harder. Distance of OC, or the length OC, is going to be, well, we kind of have a Pythagorean problem here because it's just distance from the origin to a point. So we have square root of 48 over 25 squared plus 36 over 25 squared. Now, I could do this on a calculator, but I'm just going to notice that there's a common factor of 12 over 25 squared. So I'm just going to take that out. And that just leaves 4 squared plus 3 squared, which is 5, as we know. So that's just going to turn into 12 over 5. Okay. Again, the distance between B and C, we have to actually use the distance formula this time. So we don't have a nice simple Pythag. So we have 48 over 25 minus 0 squared, so that's just 48 over 25 squared, plus 36 over 25 minus 4 squared. So, again, put that into the calculator, and we get 16 over 5. And finally, distance between A and C. Okay, so we have square root of 48 over 25 minus 3, all squared, plus 36 over 25 minus 0, so just 36 over 25 squared. And we put that into the calculator and get 9 over 5. Okay, so last part of this question. Let's confirm OC squared equals AC times BC. So is 12 over 5 squared equal to 16 over 5 times 9 over 5? Well, yes, because 5 squared is the same as 5 times 5, 12 squared is the same as 16 times 9, 144, and is OA squared, so that's 3 squared. Is that equal to AC times AB? So is that equal to 9 over 5 times 5? Well, yes, 3 squared is 9, and the other side is 9. Excellent. I just want to point out one last thing about this question. Having a look at the question, OC squared is equal to AC times BC. So What this question is saying is that the altitude coming from the right angle of a right angle triangle, the length of that squared is equal to the product of the two halves of the side it meets. Okay, that was the one thing. The other thing says that the square of one side is equal to the length of the hypotenuse times the length of the altitude. Okay, now I don't know if you're ever going to actually come across this again, but this is a kind of interesting thing about right angle triangles that you've just proven. But that was just an addendum, and hopefully you understood everything I've just said. Thanks.